Okay, let's continue the next section with our study of integrals. And we want to find the integral of this function over the interval 5 to 9. And obviously there's a problem because our function changes. It's a piecewise function. Our function changes in that interval, and so what are we going to do? Well, the answer is we can do this. Let's say you've got some integral, f of x dx. And let's say there's some break in the middle that we need to work around, some point C in the middle where there's a jump or a discontinuity. We can actually integrate around that. So let's say that there's a point C in the middle where the function jumps. So to draw you a picture of what's happening, let's say that we want to integrate from A to B, right? And then at this point C it jumps. Well, we can just integrate from A to C and then add that to the integral of C to B, and we'll be fine. So you can just do one integral from A to C and then add that to the second integral of the same function from C to B and be fine. So this integral would look like this. We would start by integrating from 5 to 7, and then we're going to be doing the first function, 8x plus 1. And then we can mind the gap and then integrate the second function from 7 to 9. And when we do that, we'll be fine. So that's how you would integrate this one. You would just jump from 5 to 7 and then go from 7 to 9 for the other function. So if we do that real fast, this will be 8x squared over 2 plus x, evaluated from 5 to 7, plus 92x minus 5x squared over 2, that evaluated from 7 to 9. Okay, and so we got a little bit more work to do. So let's just do this first one. So that'll be 7 times 7 is 49. 49 times 8 is 392 divided by 2. So that's going to be 196, plugging 7 into that, plus 7, minus, now plug in the 5. 5 times 5 is 25, times 8 divided by 2 is 100. Minus 5, because remember when we do the evaluation, it's minus, minus, minus. We have to apply that minus to everything. So all four of these values come from first doing 7 and 7, and then doing minus, plugging in 5, plugging in 5. Okay, the second integral will be 92 times 9, which is 828. Minus, plug in 9 there, that's 81 times 5 divided by 2 is 202.5. So that's plugging in 9 and 9. Now we do 7 and 7, but remember we need to subtract it or just flip the signs. So 92 times 7 will be minus 644 because we're doing the minus part of the evaluation. And then here we do minus this, which will turn it into a plus. Plug in 7 times 7 is 49 times 5 divided by 2 is 122.5. So if we just add all of that up, we will get our answer. 196 plus 7 minus 100 minus 5 plus 828 minus 202.5 minus 644 plus 122.5. All right, I get an answer of 202 as the area. There's a possibility I made a little calculator mistake because I had a lot of numbers to type in with gloves, but hopefully I did not do that. So I believe that's the correct answer. Again, don't forget that it's okay to get a negative answer. If you get a negative answer, that simply means that more of your area is below the x-axis than is above. Let's do this next example and we'll wrap up the video. This time we're finding the integral between two curves instead of between one curve and the x-axis. But luckily, this is pretty easy to do. There's just one extra step we have to do. First, you need to figure out what function is above and what function is below. So here we have a line function and we have a x to the fourth polynomial. The x to the fourth is going to be the curvy one, and this line is going to be the linear one. So the line is above the parabola. Okay, well, it's actually not a parabola, it's x to the fourth, but the line is over the polynomial curve. All you've got to do then to find the area between, let's say you have f of x and g of x, All you got to do is find the area between their intersection points of the function on top minus the function on the bottom, and that's all you've got to do. So our 2 points we're integrating over are these 2 intersection points. So we integrate from -2 to 4, which are our 2 x values that we're integrating over. And then it's just going to be 16x plus 128, which is the function on top, minus x to the 4th minus 4x cubed plus 12x squared. Sorry, that should be a minus sign right there, dx. So that's all you got to do to evaluate this one. Function on top minus, notice the parentheses, I got to subtract the entire function on the bottom. Now, importantly, let's say that this function doubles back on itself or something, and for one time, one function's on top, the other's on the bottom, and then a little later it flips. That's okay. If that happens, you just use the technique that we did up here, where we broke it up into 2 different integrals. But here we're okay because one function's always on top and the other one's always on bottom. So this is going to be the integral from -2 to 4 of 16x plus 128 minus x to the 4th plus 4x cubed minus 12x squared dx. Let's integrate. It'll be 16x squared over 2 plus 128x minus x to the 5 over 5 plus x to the 4th. That's a good one. Minus 12x cubed over 3. That whole thing evaluated from -2 to 4. Okay? And so double check all of my antiderivatives and make sure if you take the derivative of them, you get the one up above. And let's go ahead and just calculate this whole thing out. This will take a little while, but we'll do it. So that'll be 16, let's see, 16 times 4 squared is 16. Divided by 2 is 128, so it'll be 128 plus 128 times 4 is 512 minus 4 to the 5th divided by 5 is 204.8 plus 4 to the 4 is 256 minus 4 times 4 times 4 is 64, so 64 times 12 divided by 3. So those are all the values for evaluating for 4. Now we evaluate for -2, and remember we need to subtract each one of these because it's f of b minus f of 8. So plug in a 2 here. 2 times 2 is 4. 4 divided by 2 is 2. 2 times 16, so that'll be minus 32. Minus 128 times -2, which is -256, so that'll become plus 256. So careful, a lot of negatives can run around in these problems. And then we do minus 2 to the 5 divided by 5. This will be minus minus, so it'll be plus 6.4. Minus 2 to the 4 is 24816. Minus minus will be plus, but then there's one more minus from the triple negative, so it turns minus again. So there's 3 minuses there. One from subtracting the second function, 1 minus from there, and 1 minus from plugging in -2 to the 3rd power. So 3 minuses make 1 minus. 2 times 2 times 2 is 8. 8 times 12 is 96. Divided by 3 is 32. So it's okay if you miss these a couple times because there's a lot of places that we can go wrong when we're doing this, especially with the minus signs. 128 plus 512 minus 204.8 plus 256 minus 256 minus 32 plus 256 plus 6.4 minus 16 minus 32. Now on this problem we would expect to get a positive answer because we're finding the positive area between these two curves. So we just figured out that that area right there is 617.6. It's an exact answer even though it has this curvy side right here. Now I have to put a disclaimer, there's a tiny chance I might have made a mistake in all of this, but at least this technique is correct. Top function minus the second function, antiderivative, and then you just evaluate that result from 4 to -2, do 4, and then subtract the -2 result. All right, in the next video we will do some more applications.